Now let's do the 21st. Okay, limit cosecant x minus cot x when x approaches 0. Okay, now when you put the value of x 0, when you put 0 here, see, you get cosecant 0. Cosecant 0 is undefined according to the trigonometric ratio table. If you see that table, you can see that cosecant 0 is undefined. That's infinity. Okay, we write it as infinity. And cot x is also undefined, that's also infinity. So it becomes infinity minus infinity, which is undefined, indeterminate form. Okay, so let's change this. Okay, so let's bring it to in the form of sine and cos, so that we can use the theorems, that is sine x upon x, which is equal to 1. Limit x tends to 0. Okay, let's, for using this, so let's convert this. Okay, change this. Cosecant theta is equal to 1 by sine theta. Okay, and cot theta can be written as cos theta upon sine theta. Okay, so let's change this to limit 1 by 1 by sine x minus this as cos x upon sine x. Okay, limit x tends to 0. Now if you take LCM for this, you have sine x 1 minus cos x. Okay, limit x tends to 0. Now when you look at this, see, this can be changed to this form, to the theorem. This also has a theorem. Okay, this form also resembles a theorem. Let's say that is, now this is limit x tends to 0, sine x upon x is equal to 1. Now this can be written as 1 minus cos x upon x is equal to 0. Limit x tends to 0. See, there are two theorems. Okay, so let's try to bring this in this form. Just simply multiplying the numerator and denominator. So dividing the numerator and denominator by x. That is, now let's divide this. 1 minus cos x upon x. To balance it, you multiply again with an x. Okay, multiplied by x, whole divided by sine x upon x multiplied by x. Limit x tends to 0. Now see, this both get cancelled out, so you have this and this. Now see, this is in the form of the theorems. So simply this can be written as, this is 1 minus cos x upon x when x tends to 0 is 0. This becomes 0 and this becomes 1. So this becomes 0 upon 1. That is 0. Okay, that's it. This is the answer. Now you see, this can also be done using trigonometry, but this limits, so we have to use the theorems of the limits. That's why we are using this form. We are doing it in this way because we have to use the limits. But this can also be solved using the trigonometric formulas. Okay, that is, say, limit x tends to 0. If you take this 1 minus cos x upon sine x, you see there is a formula, that is sine square x is equal to 1 minus cos 2x upon 2, or when you bring the 2 to the other side, it becomes 2 sine square x is equal to 1 minus cos 2x. Now we need 1 minus cos x. It's cos 2x here, so let's divide this by 2 and this also by 2. Okay, so this becomes 2 sine square x upon 2, and this 2 and 2 get cancelled. This becomes 1 minus cos x. Okay, so now this is in this form. Okay, in the same way, sine x, when you take sine x, you have a formula, that is sine 2x or sine 2 theta, which is equal to 2 sine theta cos theta. Instead of theta you can take x. 2 sine x, sine 2x is equal to 2 sine x cos x. So we need sine x here, so dividing this by 2 whole thetas, you'll have sine theta, this both get cancelled here, 2 sine theta by 2 cos theta by 2. Okay, now instead of theta we'll use x. Okay, so this can be replaced by, according to this with this, and the denominator can be replaced by this, so it becomes limit x tends to 0. This can be written as 2 sine square x by 2 whole divided by, and this can be written as 2 sine x by 2 cos x by 2. Okay, instead of theta we'll use x. Now see, 22 goes out, sine x by 2, sine square x by 2, so 1 sine x here and 1 goes here. You have the remaining sine x by 2 divided by cos x by 2, limit x tends to 0. Now applying the limits, sine 0, this becomes 0.2, sine 0.2 is 0, this becomes sine 0, and this becomes cos 0 by 2, cos 0. Okay, now sine 0 degree is 0, cos 0 degree is 1, again 0.1 is 0. That's it, this is answer. See, same answer we got it. This is using the trigonometric identities and formulas. This is using the limits, the theorems of the limits. Okay, that's it.